Hey, what's up guys? This video is for section 9.3, which is transformations of quadratic functions. What we're going to do in this video is look at a different form that is called the vertex form of a quadratic equation or a quadratic function. Before my previous videos, I showed you guys one that is called the standard form, which is a little bit different than this one. And the way you graph it is almost the same, similar to standard form, but we have to understand what is the vertex form, and especially when we have the vertex form, we can start looking at different transformations. What is a transformation? Well, think about the movies Transformers. When you look at those movies, you see a car that transforms into a huge, enormous killing machine. So that is a transformation, when you take something and you transform it into something different. Which means the size changes from a car. It's a huge machine in that movie Transformers. You guys can also move one object to a different place. That's also called a transformation because it's not in the same place where it starts with. You guys can change the size. So that's a transformation, when you change something from an object. Now here, we're not going to have any object. We are going to have a parabola, a quadratic function, but you guys can have different objects like a triangle, square, a star. When you guys think about elementary, you guys have those drawings of a star. So when you guys start moving around the coordinate plane, and this is with transformation in math, you guys move around the coordinate plane, you change the size, and that is a transformation. So that's what it says here in the definition of transformation. When a graph, and that's what we're going to look at, or a shape, this is more for geometry, you guys have different shapes, is change in size and or in position. So one of the things in transformation is called the horizontal translation. So let's look at that vertex form and understand where that horizontal translation comes from. So the vertex form is f of x equals a times the quantity of x minus h squared plus k. H is going to be a number, k is going to be a number, a is going to be a number. H, the one inside that number, tells you guys how many units you are going to translate horizontally. Now, translation is when you move. You guys go from left to right, from right to left. So the only direction you guys move is horizontally from left to right. And you guys can move 1 unit to the left, 3 units to the right, a half unit to the right. So that is your horizontal translation, from left to right. Now, what do we have to do to this number here when we have x minus, let's say, 7? You always need to change the sign in order to find out what is the h value. So if you guys have x minus 7 here, h is not negative 7. You have to change the sign. It's going to be a positive 7. So x equals positive 7. If you guys have x plus 7 here, so plus, you have to change the sign, so it's going to be negative, h equals negative 7. Your k, the k is the one at the end of the function, so you guys see the plus k here. That is going to tell you guys how many steps you are going to move vertically, or up or down. So the graph, the parabola, you move up, you move down, that's going to be your vertical translation. And vertical, that's what it is, up and down. Now for your k value, you never change the sign. You always keep the same sign for the k. Your a number, now this one you kind of already know how does it affect when you have a negative a. This is from the standard form, so that's the same thing. If you have a negative a, so let's say here negative a, you guys have the parabola going down. But there's an actually terminology that we use in transformations. When we have a negative a, we say the parabola is a reflection across the x-axis. So what that means is the parabola is going to go down. The direction will go down. And just to give you guys an idea here, I'm going to just draw a coordinate plane like this, and your parabola is going to go down. So that is a reflection across the x-axis. If a is positive, There's no reflection across the x-axis, so we know the parabola is going to go up. All right, now the number a. Notice what I have here. The absolute value of a is greater than 1, and here I have the absolute value of a is between 0 and 1. Now this one tells you guys how wide open is your parabola. So when a is greater than 1, we say that's a dilation with a vertical stretch. Now let me kind of explain what that is, okay? A vertical stretch is when you take your graph from the top and the bottom and you stretch it vertically. So this graph right here, imagine I grab it from here, I stretch it up, I grab it from those two arms, I stretch it down. What happens to the graph? Well, it becomes skinnier, narrower. So your graph will become skinnier and skinnier as the more you stretch it, as the more you stretch it up, stretch it down, it's going to become skinnier. So that is your vertical stretch. If your absolute value of a is between 0 and 1, we have a dilation with the vertical compression. Now compression means when you guys compress or crush something. So imagine that I take the parabola here from the top, I take it from the bottom, and I compress. I actually squish it like a sandwich. If you guys take a sandwich, a peanut butter sandwich, and you compress it, you squish it, then you guys will go into the middle of the graph, or you guys have the sandwich. And if you think about it, if you have a peanut butter and sandwich, you guys will have when you compress it, the peanut butter and the jelly will go out sideways. That's what happens. When the parabola is compressed, this will go out sideways, the arms. So that's going to be wider. So as the absolute value of a is less than 1, more than 0, so between 0 and 1, it's going to get wider and wider. So let me say that again differently so you guys can have a better idea. If the a value gets smaller and smaller and smaller, less than 1, it has to be less than 1, but it's smaller and smaller, not less than 0. It has to be more than 0. But as the a value gets smaller, the absolute value of a gets smaller and smaller, the parabola is going to get wider. If the absolute value of a gets bigger than 1, bigger and bigger and bigger, then the parabola gets narrower, narrower, narrower. And let me just give you guys another ideas here of wide and narrow. So let me give you guys a really narrow parabola. I'm going to have one going down with the reflection across the x-axis. So this is a really narrow parabola. It's kind of skinny, it's not that wide open, and it goes down. A really wide parabola is something like this. So that means that for the wide, this one, your a value is really small because it's less than 1. You guys have a vertical compression. If you have a parabola like this, that means your a value is high. It's more than 1. It's big because the parabola is narrow. All right, so what do you have to know how to use transformations? Well, I'm going to give you guys some functions, and you guys need to explain to me what is the transformation that's happening to that parabola. And everything that we compare with this parabolas here is going to be from the parent function. Now remember, the parent function, it goes up. I show you guys that in standard form. F of x equals x squared. That's the parent function. It goes up. The vertex is at the origin, and we don't have anything else other than x squared. So let's look at some examples on explaining the transformations of different functions. All right, guys, so here we have described how the graph was transformed from the graph of f of x equals x squared. So notice that f of x equals x squared, that is your parent function. And if you guys compare the functions here, I do have different names of the functions. So notice the parent function is using f of x. For the new function, I'm using a different letter. That means we have a different name. It's just the name of the function, so you guys don't get confused. So when I tell you guys look at f of x, well, you know this is f of x. But if I tell you guys look at h of x, well, you guys look at this function. They're different, okay? This one has an x squared, this one has an x squared, and a plus 3. This function, g of x, is also different. Compared to the parent function, x squared, and over here we have parentheses x minus 2 squared, so it's different. And p of x you guys have more numbers, negative 2 times the quantity of x plus 3 squared minus 5. So we do have, here we don't have parentheses. Over here we do have parentheses, a number outside and a number at the end. So we have different functions. So we want to know, how is this transformed when you compare it to the parent function? So let's look at the first one, h of x. So going back to the vertex form, I'm going to write it down for you guys again. We need to know what numbers we have in the new function. So the parent function, f of x equals x squared, doesn't have parentheses, but the vertex form, and I'm going to write down the vertex form here, f of x is a times the quantity of x minus h squared plus k. So I'm going to compare this one with this one. So I don't have any parentheses. So here I don't have h, nothing inside of parentheses. I do have a number at the end. That's your k value. Notice what we have, plus 3 plus k. So this number represents k. So I'm going to put it here, I'm going to underline it, and I'm going to put k equals 3. Now for the k value, you never change the sign, so you keep it the same. So what that means, guys, if you have a value of k, the parent function will be transformed 3 units up. How do I know that? Well, the k value tells you guys a vertical translation. Is it moves up 3 steps. Now your a value, look at your a value here. Your a value is 1. Look at the parent function. The a value is 1. So that didn't change. Your a value is in front of the x squared, or you can say in front of the x with the square here. So your a value didn't change. So there's no transformation in that number, in that value, but we do have a k value in the new function. You need to explain this in a sentence. What is the transformation for that function? So if we know that k equals 3, I'm going to write down the graph was vertical or vertically translated 3 units up. And that's what you say, guys. What is the transformation of the new function? Well, this number here tells you guys the graph was vertically translated 3 units up. Vertically means up or down, but you guys have to be specific. Which way did it go? It went up 3 units. Let's look at the second one. The second one, same idea. You guys want to compare the new function g of x equals parentheses x minus 2 squared to the parent function. So looking at the vertex form right here, notice we have the a times the quantity parentheses x minus h squared plus k. So I'm going to see what we have. So I notice that we do have parentheses. Inside of the parentheses, we have an h. So this number here is h. So I'm going to underline that number. And remember that for h, you always have to change the sign. So we do have a minus 2, so the h value will be positive 2. What that means, guys, h, you move the graph horizontally. And if you guys think about it, the word horizontally starts with an h. So horizontally means sideways, from left to right. Now, since this is positive 2, h, after you change the sign, h is positive 2, then that means the graph is moved 2 units to the right. If you guys look at the a value is before the parentheses outside. So here, there's an invisible 1. The parent function has an invisible 1, so that didn't change. So we're okay with that. But the graph was translated to the right 2 units. How do you write that down in a sentence? Well, you start with the graph is horizontally translated 2 units to the right. So I already have the sentence there for you guys, but that's what it says. You move the graph, you translate the graph 2 units to the right. Alright guys, now the next one, p of x equals negative 2 times the quantity of x plus 3 squared minus 5. Well, let's go ahead and compare with this vertex form right up here. The number outside of the parentheses, we do have an a value right here. We do have parentheses, so we have an h right here, and the k is right there. So let's go ahead and write those values down so we know what we have. So my A value is going to be -2. My H value, so let me go back here. A is the one outside of the parentheses. H is the one inside of the parentheses, but you also have to change the sign. So -3H equals -3. And your K number is going to be the one at the end. So we have K equals -5. You don't change the sign of K, you always keep that sign. We have to know what this means for every number A, H, and K. So A, when A is negative, there's a -2, and the number doesn't really matter, but right now we are looking at the sign negative. That's a reflection across the x-axis. This one here, you guys have H. H is horizontally translation, so you move to the left or to the right. Since it's negative, you guys are going to go to the left. And this one here, your K value, it tells you guys if you go up or down. So let me write those down for you guys so you know. H is going to be to the left because it is negative, and K is going to be down because it's -5. Now let's put everything together. Oh, something else I forgot. The absolute value of A. The absolute value of A, let's go ahead and go back to A. So we have a -2, the absolute value of -2, that's when the numbers become positive, basically. So the absolute value of -2 is +2. So that +2 is greater than 1. So that means that we have a vertical stretch. So let me write down the sentence so you guys know how to describe what is the transformation for this function. So here is the actual sentence, and I'm just going to move this a little bit high so you guys can read everything. And it says here that the graph is reflected across the x-axis, so that's your -A. It is vertically stretched, so because the absolute value of A, which is 2, +2 is more than 1, so that's a vertical stretch by a factor of 2, and that's what we have to say. We have to mention by how much, and the number right here, the absolute value of A, the number is your factor, and that's what we know by how much it was stretched. So it is a stretch by a factor of 2. If this one here is less than 1, then we say vertically compressed by a factor of 2, but right now it's greater than 1. H tells you it's horizontally translated 3 units to the left, and notice I didn't put -3 because the word left, that's what the negative means. The negative means to the left. And vertically translated 5 units up. Down. It is translated 5 units down because it's a -5 right here. So we go down. At the beginning I put the word up here, but that's a mistake. It should be down because your K value is -5. So it is vertically translated 5 units down. Alright guys, so this is my my first video for this section. I'm gonna have to make another video, so make sure that you guys check that out. If you like my videos, you can click that like button, and you can also subscribe to my channel. Make sure you guys practice, and I'll see you guys later.